used in class 10. Well, get started here. Pull that up. Like this. Welcome back. Again, sorry I'm late. Any questions before we get started? Okay, so this is the implementation and the use of a higher order function map. You're familiar with this from 110. Semantics of map are given two arrays, and in this case it's S0 and S1. And a destination array, in this case, D. Every element of D should be equal to the result of calling the function f on the corresponding elements of S0 and S1. So for example, if you have the array 1, 2, 3, and 4, 5, 6, it's two separate arrays, and you add them, and you call map with add, you get an array that has 1 plus 3, 4, 5, 2 plus 5, which is 7, and 3 plus 6, which is 9. So the exercise here is to implement map. Right, so this is, we use f in these three arrays, the way I described. And then implement add, which is the function that will, which is one function that will call on each element of the array, and then, and if you do that correctly, and run this code, then we should get this, print out the sum, which in this case it would be 11, 44, 33, 44, and then you figure it out. 11, 44, 33, 44, 55, 105. Right? Okay, so work on this in a few minutes, and then I'll do it. But, yeah. In other languages, too, that have this, the destination array might be something that's created by map. Here, the destination array is provided to map as appropriate. So you would actually take the minimum of all three stuff. But here we're going to assume. Also, let me know if you have questions. Started. Okay. Let me ask that again. Who's done? Not very many. people. Who was unable to start? Okay, I walked around, I saw a lot of people. A lot of people weren't able to start or not raising their hands. But, okay, so the rest of you were working on it. So hopefully this now will help you. If you're unable to start, that's perfectly fine. It's a cold start after the weekend where everything maybe disappeared from what you learned last week. It's fine, but we're going to do this now and be sure if after I do this it doesn't make sense, ask a question, okay? We have time to talk about this. So math is going to iterate through the arrays. So it makes sense to do that with a for loop. And in each step, math needs to call f on elements of S0 and S1 and put the result into D, the corresponding element of D. So it's going to be something like this. This part's pretty easy. This part is not as easy. When we talked about this last time, what we want to do is that, for example, add, whatever f is, it has two input parameters and an output parameter. We want to be able to set a value in add that will be transmitted back to the caller. Now, one way to do that is like this, sort of a more natural way. And then I can call it like this. Right? Makes sense. Yes? But if instead of returning the value, I want to make the value a parameter, the following will not work. That does not work. Why doesn't that work? That's right. So what this means is that D has some value. D is a variable here. There's some value in there. Well, that value is copied into C. So C is a separate variable. The value is here. So this change, let's say we called it 1, 2, and D was 4. So there's 4 here. This is initially 4. This line changes that to be 1 plus 2, which is 3. But we have not changed D. So if we want to be able to change D in add, which is what we want to do, we use something called call by value reference. We're going to pass the value of the reference to D rather than the value of D itself. So that it works like this. We change this into a pointer to C, and then here I'm going to dereference that pointer, and here I'm going to pass the address of D. So in this case now, C, the value of C is a pointer to D. And so when I say star C, I'm actually talking about this. So that means what I need to do here is the address, D sub I. Also would be fine to say D plus I, either one. And then in add, I say star C equals A plus B. That didn't work. Oh. I think that's what I said it should be, 1144, 33, 5. That make sense? Questions? So if I want to do something like this in C++, if you're not in 221, you haven't taken 221, you have to apply to 221. So you can ignore it, you don't have to know it. But most of you are in 21 or have already taken it. So you know C++. How would you do this in C++? C++ has call by reference. Right. So in C++, there's a different type. It's called int ampersand. That's call by reference. And then this wouldn't be here, so you could say C equals A plus B. And this would be just pass in B. Okay. So that's actually how call by reference is implemented. It's the same thing, exact same thing. It's just that the syntax is different. All right? Questions? So to do max, we just have to write the function max. So we can say star C equals if A is bigger than B, then A, otherwise B. And then do this. Same call by calling max. Now what I should get as a result is the max of 1 and 10 is 10, 24 and 20 is 24, 3 and 30 is 30, 4 and 40 is 44, 55 and 50 is 55. So there's the result of that, and there's the result of that. Okay, questions about that? Yeah. Sorry, a little bit louder.
Wouldn't I have to use and B, like the and sign to be in one of your equations?
Right here.
Yeah.
Okay. So that is the address of the ith element of D. Okay, so that's the same thing as this. I have two input parameters and an output parameter. I want to change what's in that array. So in terms of the array, which makes sense for the next step anyway, to draw the picture, I've got A, that's A, and B, and C, and so that call that you're talking about in math, which is F, which is where the cursor is blinking, passes in, let's say it's this, I is 1, passes in the value of this, and the address of this. So that in the line of add, where I say star C is that location. So I'm writing the result in here. I'm reading those two values. Make sense? Any questions?
But it says D is a pointer too, so address of the I is, oh, sorry, I did.
Yeah, so these are arrays of int, that's why it's this stuff. But we're going to change that now. So I would like to be able to write a version of math that would work for any type. And in order to do this, we're going to switch over into forcing everything to be a pointer, because pointers can be copied without knowing their type. We can just use the opaque pointer. So we'll do this in a couple steps. The first step is to change this from operating on arrays of ints to operating on arrays of pointers to integers. So I'm going to create another array for each of these, like that. You do that in main. Okay? And then make all the other necessary changes. Okay, so first step here is to make these new arrays. Which I'll do as yours. You can keep working. Okay? And then we're going to change the call to map so that we pass in these new arrays rather than the old ones. And now we have to change map. So the type of the arrays is now what? It's star star. So now when we're in map, we have a pointer to the integer value in all three cases. So actually at this point, I'm just going to change it directly, but you know, that taking the address of d sub I, actually that's not necessary. We can pass in d sub I itself, because that d sub I, it will be a pointer to C. But when we get to strings, we might want to do something a little bit different. So we're just gonna, hello? We're just gonna keep it like this. So we keep it like that, then this becomes in star, in star, star, in star, and in star. And I'm just adding a star to every end. And the same thing happens here. And the same thing happens here. Does this make sense?
Why do we use the void star? Or why do we
Void
have the
star?
array-
There's no void stars. What?
Why do we have the array of pointers instead of just passing it the address of the thing into the function? Like,
In what step? You mean the whole thing?
Like when we're calling the f function,
Yeah.
what is there a difference between just saying like the address of s0 instead of making it an array of pointers that are passing?
You mean D? I didn't say the address of S0. I
No,
just
it's
said,
like if you did, would you need the array of pointers as an input?
yeah. Because I want the value, so ints are not the same as pointers. So I want the values of every array to be a pointer.
So, but that's because in the function you want to change it, right? As anything.
Well, we'll talk to me after class, you're right? So sometimes it would work and sometimes it wouldn't work. So this is cleaner, and I'm trying to take you step by step to the weird case of void stars. So here I've just made a fairly mechanical change. Also have to change max. Same way. As a call to max. If I did this right, which I probably didn't, I did, we get the same answer, okay? So just a very mechanical thing to switch from this to this. And now what I can do, now that I have parameters that are arrays of pointers, now I'm going to change them into void stars. So I want, so that add is still going to add integers, and main is still going to call f with arrays of integers. But I want f itself, math itself, to just use void stars. So that's the change to make from this question.
So if we double dereference C and add, then would it be the case that only the actual ints that D points to gets changed, but the D array itself is not pointing to those ints?
Yeah, well, so you're talking about the double star, which is weird, but it's the same thing as before we had the address of this. And now we've got this. Right? So to get that, I've got to go twice. So I've got the address of this, so star, star to get there. If I just had one star, I'd be changing this, which I don't want to do. Now, as I mentioned, it's possible to remove the ampersand and then just pass in the value of this, and then you've got a single star. And that works unless you want to change this, which you might. So, and plus this is a very mechanical change, so you don't have to think about it. Just add a star everywhere. That's it. Now change all the void stars in F, all the int stars in F, the void star, and then make the necessary other changes. Yeah, so add will still, it has to conform to the calling convention of F. So it's gonna have, the parameters are gonna have to be void star, but it's still gonna operate on int stars. So it'll have to cast them. So add and max know that they're pointers to integers. F doesn't know what they are. What do you mean how many times? Because when you cast it, you change its type, so that's the one thing. Or you can create another variable that stores its type. Yeah, you would. Okay, so first step here, all these become void. So I'm done with that. Now I have to change add, because add now has to have the same signature as F. It's going to be passed as a value to max as the F parameter. So this has to become void star as well. But then, having done that, this code doesn't work at all. I need to cast these, so I like to just call these A void, B void, C void, and then I'll make a variable A, B, and C that will be the right type of those things. Exact same value, but type changed. So I'm going to do this in a weird way, to put it all in one line. And you remember that when you have this comma separated things, you take those stars are actually all part of the type. So that's the same thing as saying int star A equals AB, semicolon, int star BB equals B, semicolon, int star star CB equals C.
Have the order, swap, you have the order wrong.
Why are A and B in different orders?
Good catch. And now we just have to think about typecasting. Typecasting is not necessary when you're changing a void star to another thing or another thing to a void star, but it is necessary for void star stars. So here I don't need it because that's void star. Here I don't need it because that's void star, but here I do need it. You could have them in the other places too. Does that make sense? Same thing here. Oh. And then I also need a cast right here. So this is of type what? AP. Type what? What's the type? Int. How many stars? 2. It's this thing. It's an array of pointers to integers. So from the array part, I have a star, and then the type of each element is another star. So these are star stars, and they need to be void star star, so they need an explicit cast now. Okay, so to recap what we did, we changed maps and now it's completely type agnostic. It's using opaque pointers. We changed add, we had to change add because add is going to be this parameter. So this part here has to be the same as that part. But for add to do anything, it has to cast those back into pointers to integers. So we added this line. That line stayed the same. Same thing for max. And then we had to add the explicit casting because we now have in star stars instead of in stars. Question?
So when you're casting the void stars and in stars, can you do it in line and on the lines instead too?
Where? Which line?
Like in the line star star C equals star.
Give me a line number. You see the line numbers there.
Oh yeah, 18. Can you do just bracket stars?
Yeah, so you could use AV here,
And then just cast it.
but then this line will be hard to read. And that line is something arbitrary and it's part of the functionality of this thing. This line is purely mechanical, it's just changing the type. So it's a choice. I like to do it this way because I get the types out of the way for the beginning. And then all the rest of this is exactly the same as if the parameters were in stars. Other questions? Okay. The other questions, yes?
So if we change the definition of the add, say we add string together, the int will.
Sorry, I didn't understand.
So
Change what?
the definition of the add, like we say
Change
we
the
add,
definition of add
yeah, say we add two string together.
to strings.
Yeah.
Okay, we're gonna do that now.
Okay.
That's the next task. Yeah.
Can you go down? Yeah, I was still, can you explain the part where you added the big star stars to the, what did you add?
This line right here,
No, for.
give me the line number. Can you see it?
37.
37.
Star stars, why do you add them if you can?
So then, sorry, you're right. That should be voice. Thank you. I was about to discover that when I tried to compile it, so you saved me. Well, you didn't save me from being embarrassed. Any other?
Why do you have to cast them if they're typed void?
Yeah, so they're not typed void star. So void star does not have to be cast, but because they're void star star, I know it's kind of weird, but it does require the cast. And the reason why it's subtle, that a void star is a pointer to, could be anything, but a void star star is a pointer to a void star, which actually is a type. I'll take off. Okay, so now we have a map that can map anything. So when we use map now to concatenate two strings. So the input now is going to be, these three arrays, but this is going to point to strings. So you can just use quote, quote, for what you want those values to be. And this will be an array of pointers to strings. You can use the string cat function, which is a built-in function in the C library, to do the concatenation. What this does is it adds this to that. One thing you have to do when you do a string cat is you need to have a destination string that's big enough. Because remember, strings are just arrays of characters. So you're going to need to call malloc somewhere. Okay? Don't worry about the memory leak. You're going to have a memory leak. Don't worry about that. If we have time, which we won't. Okay. So concatenate two strings. So that's what you would start with. No, it's pairwise concatenation. So the result should be an array that's A, X, X, X is the first element, B, 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 Y, Y, Y is the second element, C, C, Z, 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 Z. So the call is going to look like this. Print like this. Okay, so we're running out of time, so we're gonna, yeah, question? Yeah, thank you. We need it. In the right place. Okay, so let's write concat. Okay. So what I've got now is I've got a pointer in C, pointer to the array element, but it's null. So I have to malloc that. So I have to say star C, and this is why we did this as the address of the element in the array. So I say star C equals malloc. And it's got to be the length of the two source strings. Plus 1, because we need room for the terminating null. And then I'm going to say star C sub 0 equal null. And then I can say string cat star CA. So now, so I've concatenated A with the null string, because it's the null, the empty string. And then again, string cat. B. Okay. Oh, I wish it had worked. Oh. Plus. You gotta tell me when I make mistakes. You gotta be confident in your. So, I don't know what those two things. Oh. There's only 3 of these. Okay, so that's it. And time's up. So no time for questions. Okay. So, if you have questions, come down here, whatever.